Hi everyone and welcome to but Physics 111. And for this video and the succeeding ones, so the succeeding videos as well, we will discuss the motion in two dimensions, so kinematic in two dimensions. Uh, so the first topic or the subtopic that we will discuss is the position, velocity, and acceleration vectors. So we have already discussed this one, but we will level up from the one dimension dynamics into the two dimension dynamics or the two dimension kinematics of a particle. And then we will also discuss what if we have a particle with constant acceleration in two dimension motion, and then the projectile motion, and then the relative velocity and acceleration. So I won't include the rotational motion at this point. I will just discuss this on the dynamics portion of the section of this course. So so to start off, we have the displacement vector. So moving on, no, so just to have an overview of what we discussed before. So in the previous topic, we have one dimension. So it could be in terms of in x only or y only. So meaning the motion could only be translating horizontally for x, no? And it could be only translating from or vertically in the y only. So if you can remember the y only motion, the first example that we had was the free fall, you know? And then the x is the horizontal motion of the car and the motorcycle. So now we will combine these two. And if we combine the x and y, we have a two-dimensional motion wherein we treat or we include or inclusive na po yung x and y coordinates for two dimensions. So for this one, if we want to notate this dimension, we usually notate the 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 vector r, no, as it contains the x and y coordinates. So we will discuss this later. So to find the displacement, you want to find the difference between the two vectors, RF and RI. So RF is the initial, sorry, the final vector of the possession, and the RI is the initial vector of the possession. So graphically, if we have two vectors and then we connect these dots, no, for both of the tips, it is actually the difference. So what is the proof of that? So as we remember before, if we are adding vectors, no, if let's say this is Ri and let's say this is Rf, the way we add vectors is when we connect them as, no, as this visualization. So if this is Rf, sorry, this is Rf vector, then the sum of this will be the connecting point from the initial point to the terminal point. But if you want to find the difference, so let's say again, so this is Ri plus Rf, no? This one. So if you want to find the difference, if this is Ri, okay, and in this equation, Ri is negative, so we can swap the position or the vector's direction. So this will become now the Ri or the negative Ri vector. And then if you want to add the RF vector, as you can see here, we can now put now from the tip of the Ri into this RF. So as you can see, if we add these two vectors, we can form this difference, or actually the addition. So this will be RF vector plus negative Ri vector. Or in other words, we have RF minus Ri. So this difference here will be the RF and Ri. So just a review of vectors. Ano? So incorporating also the velocity, we have two types of velocity. We have the average velocity and the instantaneous velocity. So we are already familiar with average velocity. That is just the slope, no? So the rise over run. But instead of just the y in the numerator or the x in the numerator, we have the displacement r. So we will discuss more. We will have more details into this later on. no? But again, we have this delta R or the displacement in two dimensions over time. So the rise overrun pa rin, no? Essentially, but again, in two dimensions. And then for the instantaneous velocity, again, for the instantaneous, this is just the derivative, no? Or the slope of the tangent line at that point. Okay, so this green line here is the instantaneous velocity, and this one, no? So let's say we have an initial velocity, sorry, initial position, and then a final position. Then the slope of these 2 points will be the velocity. Okay, so let's move on to the next slide. So for average acceleration, if we're talking about average acceleration, we are still talking about slopes, no? So the slope of your initial and final points with respect to the plots of their velocities, no, will be your average acceleration, you know? And if you want to have the instantaneous acceleration, again, that is just the derivative. The derivative of the velocity is the instantaneous acceleration. Okay, so there's no difference here. We just have two dimensions, no, to incorporate. Now, let's have this concept quiz. So, consider the following controls in an automobile in motion with a gas pedal, a brake, and a steering wheel. So, what are the controls in this list that can cause an acceleration of the car? So, we have this. So, all three controls, gas pedal and brake. Gas pedal and brake, only the gas pedal, or only the steering wheel. So, what is an acceleration? Let's first define an acceleration before we can define whether, no, what is or what are these three controls that can affect the acceleration. So we know that acceleration is just the change in velocity. So if you have instantaneous, the change in velocity over the change in time. So what is velocity? So velocity now is, well, it is just a quantity with speed and direction, di ba? So anything that changes the velocity will change the acceleration basically. So if we can change the speed, then we can change the acceleration. If we can change the direction, we can also change the acceleration. So let's check this out now. So for the gas pedal, so you can change the velocity by, no, decelerating the car. No? So we can change the speed. So the gas pedal, sorry, gas pedal implies the accelerator. No, sorry. So the gas pedal will increase your acceleration. So therefore, it will it introduces acceleration. So it will increase your velocity. Therefore, it will affect the acceleration. How about the brake? So the brake will decelerate your car. So it will reduce its velocity. So there will be a change in velocity. Therefore, it also affects the acceleration. And then lastly, the steering wheel. So for the steering wheel, what happens when you steer? When you use the steering wheel, and also you change the direction of your motion. So if you change the direction, then the velocity will change. And if there is a change in velocity, then there is acceleration. So the answer here is that all three controls will change the acceleration of the car, or will cause, no, the acceleration of the car. Okay. So acceleration can mean two things. It could be also deceleration, ano. So don't forget that. Okay, now so let's have this important concept of two-dimensional motion. So again, we discussed the r vector. So what is the r vector now? So r vector is just the hypotenuse of our two coordinate, our two component vectors, the x and the y vectors. Okay, so incorporating these two using the vector addition, then therefore xi plus yj is equal to the vector r. Okay, so therefore also the velocity vector will be the same, no? So for the velocity vector v, that will be the sum of vxi plus vyj. Okay, so let's discuss about how can we imagine if, or how do we imagine, or how do we model the two-dimensional motion, no? So for this first scenario, so the first scenario A, so this scenario A, as you can see, let's say we have a hockey puck, and this hockey puck is moving towards the right, no? So there is a motion here, a velocity here to the right side. So as we can see here, we have a constant velocity here. And that's basically it. We already know this. But what if a hockey puck is accelerating or moving, not really accelerating now, but moving with a velocity in this direction, ano? So this is the motion of the hockey puck. How do we imagine its two-dimensional motion relationship? So as we can see here, the hockey puck is moving relative to the x coordinate to the right. And then the hockey puck is also moving for the y coordinate with respect to the y. So there is some addition. No? So as you can see, there is a direction here for the velocity of x, and there is a velocity here in terms of y. So therefore, their sum will be just the velocity of your particle. So again, you can break down any motion in two-dimensional into its component vectors, the horizontal and the vertical motion. So these are vectors, guys. No? Ayan. Okay. So therefore, your velocities will be treated in a similar manner. No? So if we are considering constant acceleration, then it has acceleration in x, it has acceleration in y. So therefore, the final velocity, if you can remember, the final velocity is just vi plus at, right? So it could be different if it is in terms of x or in terms of y. So since we have the velocities or the final velocity is equal to the sum of the two dimensions. So this is the horizontal component, and this is the vertical component. So together, they have this final velocity which incorporates their magnitude and direction. Okay, so we can rearrange this one. We can include, or we can what do you call this? We can combine, no, in some sense, like terms. Okay, so vxi and viy as the initial velocities, and then the accelerations will be included. No? So therefore, we could simplify this into its initial velocity and its acceleration. So this can be broken down into this and this one into this. So remember these equations. This will be important later on. So the visualization of that using a graph. So the vector addition of the initial velocity vector plus the acceleration vector times time is equal to the final velocity. Okay, so this is a lot of this is a lot of information to take in, but I think you can practice using the problems that I will give you during class. So for the final position, we have r sub f, no, which is the final position, no, r sub f vector. So as we can remember, we have let's say y, no. So y final, that is equal to y initial plus vyi times time plus 1/2 acceleration in y times time squared. So for the possession in two dimensions, we have two components again. So this is again the horizontal, no? So similar formula. And then this one is for the vertical. Vertical, no? So in terms of x, horizontal is in terms of x, vertical in terms of y. Okay, so we can combine also the like terms here. So we can also write our final velocity in terms of this. Okay, ayan. So for the graphical representation of the final position, we have the vector of addition of these three vectors. So we should have the initial position, we have the initial velocity, the constant acceleration, and then we can find the final position. Okay, this is a bit confusing for now, ano, but I will just discuss an example later. Ayan, ito na pala, no? So a particle moves in the xy plane starting from the origin at t is equal to 0 with an initial velocity having an x component of 20 meters per second and a y component of negative 15 meters per second. The particle experiences an acceleration x direction given ax is equal to 4.0 meter per second squared. So we can represent this particle in this graph, no? So as we can see here, it starts from the origin and then it translates in this, it looks like a parabolic pattern, no? Parabolic path, okay? So we have an x component and we have a y component, okay? So x component, that is why it is positive, and then that is why this is negative because the y component is negative. So that is why this is the graph. So what are the givens here? So we have the initial velocity is so Vxi is equal to 20 meter per second. We have the Vyi is equal to negative 15 meter per second. And then the particle accelerates or experiences an acceleration which is 4.0 meter per second squared. So we want to find the total velocity at any given time. So basically the final velocity at any given time. Also the function of the velocity at any given time, that is what we are trying to find. So to find the final velocity, so this is equal to what? You know? So we have Vxi plus a sub x times t I hat. So this is for the horizontal component, if you can remember. And then we have Vyi plus ay t and then j hat. Okay, so for Vxi, we have a given Vxi, acceleration is given. So time is just an arbitrary variable, no? And then we have a given Vyi, initial velocity in y. So it is not explicitly expressed, no, that there is an acceleration in y. So therefore, we can assume that there is no acceleration in y. So this will be 0. So substituting the values, the final velocity vector at any given time, we have, so Vxi is 20 meter per second plus the acceleration, no? So I guess I won't write the what do you call this? The unit anymore, or the units anymore. No? So I'll write this as it is. We have plus 4 plus 4.0 t, okay, and then I hat, no? And then plus we have Byi, so Byi is negative 15 meter per second plus 0 and then j hat. So simplifying this, the final velocity vector will be 20 plus 4.0 t I hat minus 15j. So this will be your velocity vector. So don't forget the units now. So this is in meter per second. Okay. So at any given time, if you substitute any given time here, you will get a velocity vector which represents their horizontal velocity and their vertical velocity. So calculate the velocity and speed of the particle at 5 seconds. So already we have already solved the velocity in last slide. So the velocity function or the final velocity is we have 20 plus 4t I hat minus 15 j hat in this is in meter per second. So to find this final velocity, we have a given, no, a new given, t is equal to 5 seconds. So therefore, the final velocity, we have here 20 plus, so 4 times 5, no? And then this is in high hat. I think we have a braces here, yeah. Minus 15j, and then in meter per second, no? So we have 20 plus 20, we have 40 I hat minus 15j in meter per second. So this will be your velocity. Ano? So what does this mean? What does this mean? So meaning you have at any given, let's say this is your when t is equal to 5 seconds. No? So therefore, you will have here a horizontal component. So I will just write here. You will have a horizontal component of 40 meter per second and a vertical component of negative 15 meter per second. So you can compute its speed as well, ano? So we can also find that the angle here, actually you can also find the angle here. So what is the angle here? You can use the arctangent, no? So tangent theta is equal to, so assuming that this will be constant, so I'll just make this the absolute value of 40 over negative 15. So therefore, theta here is equal to arctangent, no? So I'll just compute the theta here. So this will be just arctangent. Where's the calculator? Ayan. So we have arctangent 40/15. So absolute value. So make this positive. So this will be 69.44. Okay, so this will be 69.44 degrees. Okay, we can also incorporate this to our sorry. So this should be 15, ano? Oh no. There should be so the opposite nga pala is -15. Sorry. So there should be 40 and the numerator should be 15. Ayan. So we have 20.56. 20.56. Yeah. Sorry. Diba? Okay. So moving on, we also want to find the speed. So what is the speed? So the speed of the particle is basically just the magnitude of the velocity. So we are not incorporating the direction anymore. So we just want the what is the actual velocity or the actual speed is. So as we can see here, the velocity here is, the speed here is just the hypotenuse of this triangle. No? So basically the magnitude of this vector. So therefore we want to find the, the square root of 40 squared plus -15 squared. So basically the hypotenuse. So we can use the Pythagorean theorem to solve for the final speed of our particle. So this will be equal to, so square root of 40 squared plus, so this will still be positive, no? Or this will become positive. So I won't write the negative anymore. So we have 42.72 in meters per second. Yeah. Okay. Okay, so we have one last one. So determine the x and y coordinates at any given time t. So how do we now find that? So the RF, no, the possession vector R is equal to, again, no, so this is along one. We have xi plus vxi times time plus 1/2 of ax t squared. So this is for the horizontal coordinate. And then for the y coordinate or the y component, we have yi, initial y, plus byi t plus 1/2 ay t squared, and then j hat. So what are the givens here? So xi, what is xi? So xi actually is the initial position here, which is already given here, no? Starting from the origin. So meaning the origin here is the xi is 0, the yi is 0. So we can cancel this xi and yi. So for the velocity, initial velocity x, this is given. Time, so we want to find the function of this position at any given time. So we do not need that. Acceleration is given, time is given, initial velocity. So the acceleration again is 0, so we have to make this 0. So therefore the position vector is vxi. So vxi is 20 meter per second, and then times time. Okay. I will limit pala the units, no? So t, and then plus we have 1/2, sorry, plus 1/2 ax. So we have ax is 4 meter per second, and then t squared. And then we have I hat plus we have byi. So the initial velocity is -15, and then times time, and then j hat. So this will be already your answer, no? So we just simplify this. So we have 20t plus, I'll make this longer, no? Yeah. And then we have 2t squared I hat minus 15t j hat. So this is already your answer for the coordinates in x and y. So basically what you can find here, so if you can remember, we have the r vector. The r vector is equal to x I hat plus y j hat. You can remember. Therefore, this coefficient here of this I hat will be your coordinate in x. And also this negative 15t will be your coordinate in y. So you can find the x and y coordinates using this. So we have 20t plus 2t squared in x. And then for y, we have negative 15t. So substitute the value of t here, you will find the coordinate of x and y given time t. In seconds yan, no? If you analyze the, the units. Okay, now, so moving on. So from this general two-dimensional motion of a particle, let's now imagine the projectile motion. So if you throw a particle at an angle theta I, no, with an initial velocity vi, you can predict its motion assuming that there is no or there is no or the air resistance is negligible, no, to how far it will go or how high it will go or at any point in this trajectory. So this path is called the trajectory using the principle of kinematics or the principles of kinematics. So the first assumption that we know is that this particle, no, if we imagine we throw this ball, it is experiencing uh the acceleration due to gravity. So there is an acceleration vector going down. We notate this as the g vector or basically just the acceleration in y vector, which is negative since it is downwards. Ano? So again, the particle is experiencing this pull of this gravity. And then the horizontal acceleration is zero, meaning the constant velocity or meaning constant velocity. So if you throw a ball, if you can imagine, no, really, will the horizontal component of the ball change all throughout its path? No. So in this particle model, as you can see, there is no change in the horizontal velocity component because there is no air resistance. No. So meaning there is no counter or there is no opposing force that could change or could influence the velocity in the horizontal direction. So basically, what is changing in the projectile motion is only the vertical motion, or sorry, the vertical velocity. So the vertical velocity starting from here, it will get slower and slower until it reaches the top. So the vertical velocity at the very top, no, or the very top point, which is the maximum height, is zero. So the velocity of the particle in y is zero. And as we go on, no, it will also transverse. It will be just an opposed version. And also you can see asymmetry here. So this is the same curve as this one in just in mirror form. Ano, symmetric siya. Okay, so remember that the acceleration in the x direction is zero and the initial velocity component in x, no, initial velocity horizontal component, okay, is constant. So it will be the same all throughout. So the velocity here or the horizontal velocity in x here will be constant in here and here and here. Okay, sige, let's see here. Okay, air resistance of negligible. So for the position vector, we connotate this in this form. So we have the final position or sum f, which is equal to Ri plus Bi times T plus 1 half A D squared. No? So kindly remember this one. And then the initial velocities. So how do we find the initial velocity? So if this is your initial velocity, then there is a component in x and y. Ano? So if you can imagine, this will be your component in x, right? And then you have a component here in y. So these are vectors. So therefore, the relationship of that, so we have the initial angle here. So therefore, we have cosine, no? So for the cosine, you have cosine theta I is equal to Vxi over Vi, no? So basically this length here or this vector here is this VI, no? So, sorry, it is only in the magnitude nga pala, no? So, therefore, VXI is equal to VI cosine theta sub I. So, that will be the same for sine theta I. So, this will be the opposite. This will be the hypotenuse. So, this will be VYI over VI. So, VYI is equal to VI sine theta I, wherein, again, theta I is just the initial angle or the launch angle, and VI is the initial velocity. Okay. So again, now to take note, the horizontal velocity will be constant throughout the trajectory. All right. So again, the projectile motion has two components, the horizontal component and the vertical component. So to make things easier, you can break things down, no? So just consider the horizontal motion, you can consider only the vertical motion. They are independent of each other. So for the horizontal motion, we have only three things to consider, no? So the easiest one is the horizontal motion, since again, it will be constant all throughout the time, okay? But its horizontal position, x sub f, will vary, no? Depending on its velocity and its initial position. For the vertical motion, there are a lot of things to discuss here. So basically, every kinematic equation is included here since it is influenced by the acceleration due to gravity. Ano? So the AY here will be negative, no? Negative G, which is negative 9.8 meter per second. Okay. So for the maximum height and range in the flat surface, so you can derive the formula for the maximum height, which is this H here, and the maximum displacement in X, which is also called the range, using this formula. So I won't show this derivation anymore. And for me, personally, it is not generalizable since usually it is not a flat surface. No? But remember this one or this two formula. So this is based on the derivation of the initial velocities and the in the y and x components. Yan. Okay, sige. Let's try solving a problem here or a conceptual problem. So we have a given graph of different launch angles of a particle. So the launch angle is varying at a constant initial velocity. So we have an initial velocity and the launch angle. So let's say 15 degrees. So this will be your trajectory. This path here, 30 degrees, this will be your trajectory. 45 degrees, this will be your trajectory, and so on. So the question here is to rank the launch angles for the five paths in the figure with respect to time of flight from the shortest time to the flight to the longest. So which of these flight path or trajectories has the shortest time to finish, no? Okay? So we have to rank them. So how do we do this? Ano? So the velocity VYF is equal to VYI plus AY times T, diba? If you can remember. Wherein AY, you can rewrite this one as negative G if you want. Also, this will be negative GT. So if you imagine this, now again, we have the trajectory. Let's say this is the trajectory in a flat surface. Okay. So this will be your initial velocity. This path here, and then it will drop at this point. So basically, again, the velocity in y will be varying. No? So from this one, this will be much slower. It gets slower and slower until it reaches this final or this maximum height. No? So the relationship of that, we can say that the final velocity, we have VYF here at this peak point. This is equal to 0. And then the initial velocity here is just your VI. So what is this? Cosine or sine? Sine theta sub I. So recalling this, now we can say that we have 0 is equal to VYI, which is PI sine theta sub I, again, and then minus G times T. So as we can see here, we have, we can manipulate this equation in terms of T. Okay, so this is the time here, this point, okay, sorry. So at this point, we have the time T, so T, no? So transposing this to the other side, we have GT is equal to VI sine theta sub I. I can delete this, yeah. So T is equal to VI sine theta I over G. Okay, so what can we see here? No? So relating this, no? This is only the time it takes for it to reach the highest or the maximum height. We want to figure out what is the time to take, no? How much time will it take to be at this point? So we have to multiply this time by 2, no? So if this is t here, then the total time here, which is capital T, this is just 2 times t, diba? So therefore t is equal to, or the small t is equal to the capital T over 2. So this one will be equal to T over 2 is equal to BI sine theta sub I over G. So therefore, the T here is equal to 2VI sine theta I over G. So what is the significance of this? So meaning, we can establish a relationship assuming that the velocity and the acceleration due to gravity is constant. If the theta I is varying, we can establish a relationship of this 5 different launch angles. So if your angle is low, as you can see, if your angle is low, then it will the time here will also be lower. So sine 0 is 0, sine 10 degrees is lower than sine 30 degrees. Okay? So as you can see, the relationship here is direct. So the higher the angle, the higher the time. So therefore, we can arrange this that the time it will take for the 15-degree launch angle will be less than the time launch at 30 degrees, the time launch at 45 degrees, the time launch at 60 degrees, and so on. So the shortest trajectory, or the particle which has the shortest time to finish, no, is the 15 degrees. The longest one will be 75. Okay? So that's it. Ayan. Okay, so another problem here. So a long jumper leaves the ground at an angle of 20 degrees above the horizontal and the speed of 11 meters per second. So how far and does he jump in the horizontal direction? So we can imagine this as a particle, no? This point, and then it has a projectile motion with this point. So how do we find this horizontal displacement? This is basically just the range, no, or the R. So the R is defined as, we have VI squared sine 2 theta sub I over G. Okay, so is R is given, so the initial velocity is given, okay, and then the theta I is also given. So we can solve for the R, no? So G is always given. Okay, so R is equal to, we have VI, we have 11.0 meter per second squared. And then we have sine 2 times 20 degrees. And then all over G, okay, which is 9.8. No? So in this formula, we can utilize positive G. So we have here 9.8 meter per second. All right. Meter per second squared. So the final unit will be meter in meters. So therefore the R here, so calculating this, we have 11 squared sine 40 na lang, no? All over 9.8. So 7.9375. So the R here is 7.9375 meters. So this will be your final range. Okay? For the final possession. So if this is 0 meter, this will be 7.9375. Okay. So what is the maximum height reached? So again, model this as a projectile. So we can define this maximum height, no, at this level here as your h. So your h is defined as we have vi squared sine squared theta sub I all over 2g. So the initial velocity is given, the angle is given, the g is given, we can find the h. So to remember, this is only applicable for flat surfaces if the level is the same here and also at here. Now this is only applicable for this formula is only applicable for this scenarios. So this will be 11 meter per second. Delete this 11.0, no? If we consider the significant figures, and then we have sine, we have theta I, which is 20 degrees, square this, and then all over 2 times 9.8 meter per second squared. So the maximum height h is equal to 11 squared times, we have sine theta, no, sine 20 squared all over 2 times 9.8. So you have 0.722 meters. So 0. Sorry, you have to write this as h. So h is equal to 0.7222 meters. So this will be your maximum height. Okay. So another problem, so a stone is thrown from the top of the building upward at an angle of 30 degrees to the horizontal with an initial speed of 20 meters per second, as shown in the figure. The height from which the stone is thrown is 45 meters above the ground. So how long does it take for the stone to reach the ground? Okay, so we have a visualization of this problem. All right. So always remember, no, one thing to consider always is the initial point is our origin all the time. So basically, the origin O, we have 0, 0 as our x and y values. So basically, your initial position in x, initial position in y is 0. So we have two givens already, no, all the time, unless otherwise specified. So the other givens here, we have a launch angle of VI. So VI is given here. The angle is also given, the initial launch angle, and the height of the building. So what will happen here? So the trajectory will continue, and the final position here will be some value. No, we do not know. This is XF, and the height here actually is what? No, since this is downwards from our coordinate system, this is our origin. Therefore, this will be negative 45 meters. No, so this will be negative 45.0 meters. So therefore, yung YF natin, no, is equal to negative 45 meters. So to find this time, we can utilize this final position YF. So YF is equal to YI plus PYI T plus, so AY T squared over 2 or 1/2, no? So we know that AY is just G, so this is given. BYI is, we can solve for BYI. YI is given as 0, YF is also given. So we can check, we can solve for the time. So how do we solve for BYI? So we can break this down. So the launch angle is, again, 20 meters per second. So it has a component in X and a component in Y. So we have a given theta here. So to find this Vxi and Vyi, you can use the trigonometric identities. So Vyi is equal to Vi sine, sine theta sub I. For Vxi, baliktad pala. Ay, tama pala, no? So Vi cosine theta sub I. So this will be equal to, so using your calculator, so Vyi is equal to, what do we have here? We have 20, right? 20 and 30. So we have 20 sine 30. Okay, so VYI is 10 meters per second. The VXI will be equal to, so you just change this and cosine. So we have 17 point, we can just use two decimal places no, in general to keep it brief. Ano? So we have a solution for VYI. So we can solve now this equation. So to find the T, okay, so the given we have negative 45 as our final position. So this position right here is, we do not know, no, this is just XF and negative 45.0 meters. Ano? So this will be YF. So negative 45.0, I think I will just set like this one. So plus 0 plus VYI, so we have 10, and then T plus, we have AY, so AY is negative 9.8, so negative 9.8, and then T squared, and then all over 2. Okay, so simplify this, we have negative 45 is equal to 10T minus 4 point, what is this? 4.90, 4.80, ano ba ito? Let's calculate this. 9.8 divided by 2. 4.9, yeah. 4.9 T squared. Okay, so we can utilize, or we can use a variety of way to solve the T here. So we can just use the quadratic formula. So just rearrange this properly, ano? So I guess I'll just put this here to the other side. So we have negative 4.9. So racking this from the highest degree, which is T squared, and then plus 10T, and then negative 45 will be positive 45. So we have plus 45 is equal to 0. So solving for T here, we have T is equal to, so using our calculator, we have mode 5, 3. So use this, we have negative 4.9, 10, and 45. Okay, so we have 4.22 and negative 2.177. So the answer here should be the positive, of course. So we have 4.22, no? So 4.22 meters. Sorry, seconds. Sorry. Okay, so that will be the time it will take for it to hit the ground. So what is the speed of the stone as it reaches the ground? So when we're talking about speed, what we're talking about? We're talking about the magnitude of the velocity. So again, it will reach this point that has a component of velocity. So this will be the direction of the velocity. You know, if you can imagine this will be the direction of the velocity here, right? So it has a component in its x direction. So we have vxi, and then we have a component in y direction, which is byi. Sorry, not byi, but f pala to, ano, the final. So how do we solve for this? Ano? We can solve this using the what? The formula introduced in previous slides. So for the vxf, we know that the initial velocity is equal to the velocity at any point, no? So this will be just the final velocity, which is computed as 17.32 meter per second. From the previous one, this is already solved. But for the final velocity, okay, the final velocity that is equal to, we have Vyi plus Ayt. So is this given? So Vyi is given. Okay, we have an initial velocity in y. We have gravity as a sub y. Okay, this is also given. So the time is given. So we already solved for the time, no? So the time it'll take to be at this point will be 4.22. So this is also given. So we can find the VYF. So VYF is equal to, so 10 meter per second plus, so this is negative nga pala, no? So plus negative 9.8 meter per second squared times time. So substituting pala the time, which is 4.22. Then the final velocity in F or in Y, and nalito na rin, no? So we have 10 minus 9.8 times 4.22. So we have negative 31.0 356. So negative 31. So include the negative sign, no? It is important to include this. 36 na lang, no? Meter per second. So what does this mean? So this confirms our graph, no? That the horizontal velocity is negative since it is going downwards. So now what is the speed, no? So the speed is actually the hypotenuse of this triangle. So how do we find the hypotenuse? We just find we use the Pythagorean theorem. So VF is equal to the square root of the sum of the squares. So we have VXF squared plus VYF squared. So this final velocity is equal to the square root of 17.32 squared plus we have 31.36 squared. So VF lang pala, no? Final velocity, square root of 17.32 squared plus, I put here a positive now because this will still be positive, no? If you put a negative here, this will become positive. So anyways, it doesn't really matter here in this scenario. So the final velocity or the speed of the particle as it drops to the ground, no, at the very instant is 35.83 meter per second or meters per second. All right. Okay, so last one for projectile. So a ski jumper leaves the ski track moving in the horizontal direction with a speed of 25 meter per second as shown in the figure. The landing incline below her falls off with a slope of 35 degrees. Where does she land on the incline? Okay, so when we say where does she land on the incline, it could mean different ways, no? So we're talking about maybe the x coordinate. So this could have an x coordinate, it could have a y coordinate, or even the distance here d, which is also possible, no, to know. So how do we do this? No? So let's define first the given. So we have an initial velocity. So the initial velocity is 25.0 meter per second. So it is said that it is horizontally, no, it blasts off at the horizontal direction, meaning this is also the VXI, you know, the horizontal component of the velocity, meaning your vertical component VYI will be zero kasi nga, no, horizontal lang to. This is only horizontal. So there is no vertical component. So diretso lang siya, no, at this specific instant at the origin. So this will be 0 meter per second. So what we want to find is, you can solve for x and y and then the d. You know? So let's formulate here a relationship of this unknown and this givens. So for this one, so what is this? This is x and y, yes. But this is also the final position in x and the final position in y. So this point, ano? So this is the final position, no, from the origin, so positive, and then the YF will be negative. Ano? Okay, so for XF, this will be equal to what? No? So XF is equal to VXI, XI pala, no? XI first, so we have XI plus VXI times T plus 1 half AX T squared. But we know that the acceleration is 0. No? So usually in projectile motion, we just have these two terms. And we know that again, the starting point here will be the origin, so 0, 0 lang siya. So therefore, your xi is 0, your yi is also 0. So this will be 0. And then the vxi is what? So vxi is given. The time is unfortunately not given. Okay, so let's not give up. Let's formulate another equation. So for the final position in y, so this yf, no, we have this relationship. So we have yi plus byi t plus 1 half ay t squared. So we have ay as the gravity, so we can make this 0, no? We cannot make that 0. So this will be 0. We know this is 0. So the VYI is also 0, no, as we discussed, since it has no vertical component at launch. This will be 0. So what remains is AY and T squared. So AY is just G. So we can write this as YF is equal to, so we can write this as YF is equal to 1 half. And then this will be negative 9.8. Okay. And then T squared. So remember the XF, no? So I will just write the XF again. This will be just BXI times T. So we have two equations here that we can use. Okay, so we want to find XF and and then YF. So we have another given here, the phi here, no? So we can imagine that the phi here will relate this distance D, the Y and the X coordinate. So we see that this is the angle P. So therefore, knowing that they are what? They are congruent angles here, no? So this is also 35 degrees. So therefore, we can create a relationship of the X and Y and the D. So again, this is your D, this is your Y, this is your X. Or in other words, this is your YF, this is your XF. Okay. So assuming that your YF should be negative, no? So don't forget that assumption as well. So this is your theta or your phi. We can say that well, we can start with sine, no? So sine P is equal to YF over D, no? So we assume that YF is negative, so we will put a negative sign here later, no? And then cross multiply this D, so D sine P is equal to YF. Yeah. And then again, YF is negative. So don't forget that YF is negative now. So I'll just write here negative YF because we will make this positive. So therefore, negative D sine P is your YF. Ano? So we have another equation here. And then for XF, we can also establish a relationship. So we have cosine P is equal to, so this will also always be positive, ano? So this is always positive based on this. So since it is transversing to the right, or translating to the right, so this will be XF over D. Therefore, XF is equal to D cos P. So we have a fourth equation that we can use. So this one can be substituted to this one. This one can be substituted to this one. So let's create another equation. Okay, so we have another equation. So we have XF is equal to dxi times t. So combining the equations, we have one, or actually we will substitute the 3 into 1. So 3 into 1. So we have d cosine phi is equal to dxi t, right? Okay. And then your equation 4. So this equation 4, sorry, equation 4 pala yan, no? I forgot. Sorry. This is equation 4. So equation 3 into 2, no? So this one can be equated or substituted as YF in this equation, ano? So we have YF is equal to negative, I will just make this negative 4.9, ano, T squared. So YF is known as negative D sine P, which is negative 4.9 T squared. Ayan. So therefore, we can cancel the signs, no? As well. So this will become d sine P is equal to 4.9 T squared. So that is the significance why we need to have a negative sign. Ano? Okay. So we are interested in finding the D, the X, and the Y. So how do we find that? What we can do, no? What we can do is we can equate, no? We can equate the T's here. So we have two equations. We have two equations and two unknowns. So we can solve a unique solution of this two equations. You know? And how do we do that? We can change this one into in an explicit function of t. So we have t is equal to d cosine phi all over vxi, right? So cross multiply this to the other side. So this will be d cos phi over vxi is equal to time. And then this one will be substituted to this one. So this will become d sine phi, no? Sine phi is equal to 4.9 t squared, which is, so t squared is equal to d cos phi over vxi and then squared. So we can simplify this. So we have d sine phi is equal to 4.9 d squared cosine squared phi over, we just have this over everything now, vxi squared. So we can cancel this d here. We can cancel 1d. And then, are this given? So phi is given, vxi is given. So we can solve for the d. Okay, so manipulate this again. We have sine phi all over 4.9 cosine squared phi and then multiplied by vxi is equal to d, right? So I just cross multiply this and then this and then this, no? So d here is equal to, we can write this one, no, actually, but anyway, so kahit hindi na. So we have sine phi vxi over 4.9 cosine squared phi. So d here is equal to, so vxi is 25 meters, and then sine phi, so sine 35 degrees all over 4.9, and then we have cosine 35 degrees squared. So let's see. So what should be the unit here? If you check this by unit analysis, this will be in meters. Okay, so calculate 25 sine 35, 4.9 cosine 35 squared. Oh, why is it wrong? I think we have something. This should be squared. Squared. So 109 now. So we forgot the squared, no? So this should be squared, this should be squared, this should be squared. So the answer is 109.03 meters for the distance. Okay, so is this the final answer? Yes. But we also want to find the x and the y. So we know that, no, where's it? So we have yf and xf here. So we can solve for yf. So yf is equal to or negative yf or negative d sine phi. So this will be negative 109.03 sine 35 degrees. And then for the xf, we have d cos phi, which is equal to 109.03 cosine 35. So the yf will be negative since it is, or the position is downwards. So we have this answer times negative sine 35. So the answer is negative 62.54, okay, in meters. And then for the other one, we have 109 cosine 35. Ayan. So we have 89.20, 89.29. Okay, so this will be your final answers. And that will be all for the projectile motion. Okay, so last one. So let's talk about the relative velocity and acceleration. So if you're talking about relative acceleration and velocity, we can think of a scenario. This scenario, if you have been in an airport, there is a horizontal escalator, no? I don't know what it's called, but walkalator. So as you can see now, if this person is walking in this horizontal escalator, I don't know what it's called. It is called a beltway, no, for some reason, but I'm not sure. So this beltway, This man is walking and this beltway is also moving. So at the perspective of this person or this woman, the boy is moving, no, at the speed it is experiencing. But if we look at this at a different perspective, so if we have someone else looking at this outside of the belt, we can see that the man is not only moving in this direction, no, and that speed, but also the escalator is moving. So we can see that the velocity of this person and this belt can be added. So your velocity cannot be determined exactly. No, we can only measure your relative velocity at a reference. We call this the reference frame. Okay, so let's see this in place with our example. So a boat crossing a wide river moves with a speed of 10 kilometers per hour relative to the water. So the water in the river has a uniform speed of 5 kilometers per hour due east relative to the earth. So if the boat heads due north, determine the velocity of the boat relative to an observer standing on either bank. Ayan. So we can imagine this problem that this boat is heading north, no? It is heading north. So let's say, I will write this down again. No? So let's say this is the boat. So it is heading north in its perspective relative to the water. So this is 10 kilometers per hour. But we know that the river has a flow. No? There is a current. There is a current here with a magnitude of 5.0 kilometers per hour. So what happens to the boat? No, if this is the current and this is the direction of the boat it is taking. So you can see it will be in this direction. So there will be a resulting velocity. No? So we can see that this will be 5 kilometers per hour. And then towards the bank will be 10 kilometers per hour. The actual velocity at an outside perspective will be this hypotenuse or the resultant of these two vectors. So therefore, this velocity, no, relative to the bank, no, instead of the water, okay, will be equal to what? No? The square root of, so v is equal to the square root of 10 kilometers squared plus 5 kilometers squared. So the velocity here will be, let's calculate this using our calculator. So square root of 10 squared plus 5 squared, that will be 11.18 kilometers per hour. No? So this will be this is only your magnitude. Okay, if you want to find the velocity, we can notate this in its vector form. We have 5, no? So 5 I hat, okay, so right, and then 10 j hat in kilometers per hour, no? This is also an answer, no? If you want to consider the vector. But if you want to also find the angles, as you can see, no, there's an angle here, which is theta. This is equal to what? We have here arctangent, no? So arctangent of 10 over 5. So I want to put this. So we have here, so yeah, I will write this down, no? We have arctangent, we have 10 opposite over adjacent, which is 5. So theta here is, uh, it depends on this is the theta that they're looking for, no? Hmm. Yeah, I'm confused. Why is that the theta? Oh. Hmm. So this is because it is a different ano pala, no? So anyways, this is our theta for now. So this will be our tangent 10 over 5. So this will be 63.43. 63.43 degrees. So what is that? So if your boat is moving here and then to the other side, ano? Actually, ito pala yung makukuha natin na theta, no? So I think we are wrong here. Hmm. Hmm. Theta. Oh, I think this is why it is harder to do this, no? What we have, what angle we have is not really useful because this is the theta, ano? So we want to find this angle, no, with regards to this figure. So this is fine as your answer, no, but if you want a useful answer, so with respect to the north, no, we can find this theta, or we can call this phi, or actually we could call this phi, no, we could just call this phi. Sorry, alpha pala to, no, ito like alpha, and this will be your theta. So this the relationship we have phi, we have theta plus phi is equal to 90 degrees. Therefore, your theta can also be calculated as just 90 minus alpha. So theta is equal to 26 point about 37 degrees. So we can also calculate. So either of these two is correct. No? As long as you visualize, you show your solution as if this is your phi, no, or this one. Okay. And then next one. So same problem, and if the boat travels with the same speed, 10 kilometers per hour relative to the river, and is to travel due north as shown in the figure, what its heading should be. So the second figure is this, and the question is what should be the heading. So it is already traveling at this speed, so 10 kilometers per hour, no, relative to the river. So this will be the 10 kilometers per hour. Okay, and then we have here a component of this, and then the river is trying to counter that act, no, counteract this velocity. So this will be 5 kilometers per hour. So to get this uh vertical component of the velocity, which is also the heading, and sorry, the heading is actually the angle, no. So we're trying to find the angle here, and we also find the velocity anyways, no? So you can find the angle directly here. As you can see, we have sine. So this is phi. So sine phi, sorry, theta is equal to, so we have the opposite 5 over 10. So theta is equal to just arc sine 5 over 10 or 1 half. So this is equal to sine 1 half is, or arc sine 1 half is 30 degrees, no? I think. So 30 degrees. So this will be your heading. Yun lang, no? But if you want to find the velocity or the vertical component of velocity, we can also solve this. Either we use this solve angle or you can use the Pythagorean theorem. So this the answer should be the same. So I'll just utilize the angle, no, for this example. So we have cosine phi is equal to Vy over 10, right? So therefore Vy is equal to 10 cosine theta. So theta is equal to 30. Therefore Vy is equal to, so 10 cosine 30. That will be equal to 5 square root of 3, which is 8.66 meter per second. So this will be your final answer. Okay. So these two are your heading, the velocity and the direction. Okay, so that will be all for this video. I'm sorry I did not split this into separate parts, but I hope you listened, and good luck for our exercise and see you in class. Thank you, guys.